So when we verify trig expressions or equations, what we do is we have to make one side look like the other. So you can pick the left and manipulate it to make it look like the right, or you can pick the right and manipulate it to make it look like the left. But you cannot change both sides. You have to pick one side and change it so it looks like the other. So for this first problem, I'm going to take this and make it look like that, because this looks a little more complicated and this looks a little simpler. Now, what do I do to make these modifications and manipulations? I use my cheat sheet. I use all these facts. For instance, right here where it says tangent. So tangent individually could be written as sine over cosine. And in the bottom can just stay sine. And that stays the same. Now, you see how this is sine? I'm going to drop a 1 beneath it. And I'm going to write this a different way. I'm going to write this as the top, which is that is being divided by the bottom, right? The top divided by the bottom. Now, I don't want to divide a couple of fractions. I don't want to divide fractions. I want to multiply. So I keep the first one the same, and instead of division, I turn it into multiplication. But of course, we must reciprocate or flip the second fraction. And this is convenient because, boom, boom, these are gone. So it's just 1 in the numerator over cosine. And if you look, 1 over cosine, that is actually the definition of, where is it? 1 over cosine, right there. That's the definition, if you see on the cheat sheet. 1 over cosine is the definition of secant. So by substitution, here on the left, 1 over cosine can become secant of x. And that was the goal, right? Secant of x, right there. So that's what you do. You verify or you change one side until it looks like the other. And that's just, your trig verifications. How about this one here? Let's see. So I'm going to mess with this. I'm going to change this to make it look like that. Now I'm going to keep cosine the same times, but instead of cosecant, if you look at your cheat sheet, cosecant can be turned into 1 over sine. I'm going to turn this into 1 over sine. And then tangent, what can we do with tangent? Tangent can turn into sine over cosine. That stays. And now here, that cosine has a 1 beneath it, and I can multiply these two fractions in the top. So that would just be cosine over sine. Cosine over sine. And this is sine over cosine. Now we can do what we did before, where we take the top divided by the bottom. We have the top fraction being divided by the bottom fraction, but we prefer to multiply fractions instead. So what we're going to do is multiply, and we're going to turn this one upside down. And then, of course, we have cosine times cosine would be cosine squared. And in the bottom, sine times sine is sine squared. Both are being squared. So what I can do is just write it as sine over cosine, quantities squared. Now, what's the definition of cosine over sine? Cosine over sine, if you look at your identities, cosine over sine is the definition of cotangent. So in the parentheses, I can write cotangent of x squared, I should say x. And of course, this is just cotangent of x squared, which equals the original right-hand side. All right. Now, what about this one here? Let's see. So it doesn't matter which one you change, and they both look equally as difficult. So I could turn this into this or this into that. I prefer to turn this into that, and I'll tell you why. If I have cosine and secant, I like cosine. I don't like secant as much. I prefer cosine over secant. So I'm going to turn secants into cosines. Now, what's the definition of secant? Secant is 1 over cosine. So what I can do is I could turn that into 1 over cosine. And I can turn this into the same thing, 1 over cosine. And now what I can do is I can put a 1 here. I can put a 1 down there. Now, if you look at the top, I want to get a common denominator. So what I'm going to do is multiply this by cosine. And the same thing down here. I need to get a common denominator because these are two fractions that are being added. And we know that if you want to add fractions, you must establish a common denominator. So I'll just use my pen instead of my marker. So in the numerator, we have 1 over cosine x minus cosine over cosine. And in the bottom, we have 1 over cosine plus cosine over cosine. And the reason for doing this was to get common denominators. So in the numerator, we have 1 minus cosine over cosine. And in the denominator, we have 1 plus cosine over cosine. And let's do what we've been doing here lately, this trend, where instead of dividing fractions, you can multiply by the reciprocal. So I went ahead and sort of skipped a step where I just turned it into multiplication by turning the bottom fraction upside down. And look at what happens. These cosines knock out. And then we're left with 1 minus cosine over 1 plus cosine. And out of the corner of your eye, you see that that's exactly what you wanted it to equal. All right. Now, I mean, if you want to pause the video and try this for yourself, go for it. But I'm just going to dive right in. So am I going to turn this into that or that into this? I'm going to turn this into that for sure. Because this looks more complicated and this looks simpler. That's usually just the general rule of thumb. Make the one that looks more complicated into the one that looks simpler. Now, secant could be turned into 1 over cosine. And cosine, I'll keep. So the tendency is to keep sine and cosine as sine and cosine, but secant can be turned into 1 over cosine, and like cosecant could be turned into 1 over sine. So I turned both of the secants into 1 over cosines. Now, in the top, I have a fraction minus a thingy, but I'll turn it into a fraction. So now it's fraction minus fraction. But we have to get a common denominator, so I multiply this top and bottom by cosine. And so now this would say 1 minus cosine squared over cosine all over 1 over cosine. And then we can do the thing where we keep the top fraction the same, but we'll go ahead and multiply by the reciprocal of the bottom fraction. And it's convenient that these knock out. And so we have left 1 minus cosine squared x over 1. But over 1 can just disappear. So it's 1 minus cosine squared x. Now what I do want to do before I let you go here is take a quick time out. Remember that sine squared plus cosine squared x equals 1. And this is a true statement. And what I want to do here is just manipulate this identity. Let me subtract this term to this side. So that would say sine squared equals 1 minus cosine squared. These two quantities are equal. So wherever you see this, you could replace it by this. And vice versa. Wherever you see this, you could replace it with that. And look here. Here I have 1 minus cosine squared, which can clearly be replaced by sine squared by substitution. And I did that because I knew that it would lead me to what I wanted, because now these match. So this is how you do these trig verifications. Turn sines, turn like, the general rule of thumb is, if you can, turn like secant into 1 over cosine. Turn cosecant into 1 over sine. And things like that. And of course, always try to pick the one that looks crazier and turn it into the one that looks simpler. That's just the general rule of thumb.